In this video, I'm going to go through how to carry out a logistic regression analysis using SPSS. And so what we see here are our data, and these were data, hypothetical data collected on 100 individuals, and we have the continuous variable for VLDL levels, very low density lipoprotein level, and these just happen to be in numerical order, but that has no bearing on the logistic regression analysis. And each person has a success or failure type of measure for the presence of cardiovascular disease. And you'll see here that the first person has a VLDL level of 12 milligrams per deciliter of blood, and this person was found to not have cardiovascular disease, and that's different than research participant number 3 here, who had a VLDL level of 14, and this person was diagnosed as having cardiovascular disease. But in this research design, we're only going to consider one predictor as to whether a person has cardiovascular disease or not. So to carry out the logistic regression analysis, I go to Analyze, I go to Regression, and I'm looking for binary logistic. So dichotomous and binary are terms that are used interchangeably. So I click on the binary logistic, and the dependent variable, as asked by SPSS, refers to our criterion or our outcome variable, and that outcome is cardiovascular disease. So I'm just going to bring that one over, and we put the VLDL as a covariate into our approach here. Now I'm going to go under Options, and I'm just going to click Classification Plots, and then I'm going to hit Continue, and I'm going to show a limitation here in using SPSS directly with logistic regression analysis. So now that I have that set up, I go ahead and hit OK. And we have the output here that summarizes our data. So once again, here we have our sample size of 100. And I'm going to just come all the way to the bottom here, and I'm looking for the variables in the equation that includes VLDL and the constant. And you can see here we have, as indicated by SPSS under B, the two coefficients. So the 0.105 is the variable, is the coefficient associated with the independent variable or the predictor of VLDL, while the other value of negative 3.518 is the what we've termed as the y-intercept, is the lone standing coefficient. And the standard error for each of those is indicated in the next column, and the Wald statistic, as you can see here, is computed for each of the two variables in question, but with null hypothesis statistical testing, with inferential testing, we zero in on the 0.105 with the beta associated with VLDL, and we see a significant value, a significance value that's less than 0.001, and that would indicate a statistically significant correlation, and it's positive because of the positive value of the B, that as the as VLDL level increases in the population of individuals that share the same characteristics as the sample, the probability of having cardiovascular disease goes up as well. One last item I want to show here is the plot, a probability plot that is generated directly from SPSS. So you can see here that this plot here, not particularly helpful in terms of describing the data, and that's where Microsoft Excel, by using the base equations for logistic regression, might be better suited to making that descriptive graph. So this ends this video on how to use SPSS to carry out the logistic regression analysis.